We are going to start with the strings in this week, and I have to caution you guys, one second, that for next couple of weeks we would be going around arrays, functions, and pointers. All right, so we'll be going back and forth between all these three main topics. Okay, we may jump to we have currently in arrays, will be jump to maybe functions and quickly go to pointers and probably go back to functions. So these are tightly coupled modules in C language. Okay, it's just not possible to just discuss arrays and then go to functions and then pointers. It doesn't work like that. So I will be going back and forth between these three modules. Today we'll be talking about strings. Okay. In C language there is no such thing called as data type as string, like in Java. You guys must have done Java, and in Java we have string, right? We have string, say name equal to new string, right? But we don't have that thing in C language. We only have a string. It's a composition of characters in an array. Okay, we store the characters in an array, and we will go into how to determine the length and what is a null character. A simple declaration is char name 8, like I have defined here. 8 means our indices goes from 0 to 7. Here the name is an array. It's a pointer constant. That means we cannot change name pointing to somewhere else. All right, it contains 8 cells and each type is a character, like a char. All right, the last character in a string is always the null character. That's something you have to understand. For instance, if we declare a string of 8, we could only store up to 7 characters. Okay, the maximum, for instance, if our array is say 60, that means we have 60 cells, the maximum number of char characters we could store is 59, because we need one character to store the end of line, which is 0. Okay, and 0 is backslashed always, because this is a ASCII value 0. That is the very first value in the ASCII table is 0. So in the C language, the strings are always represented with the values and the null character. This is the null character. All right. So if your if your array is, say for instance 10, you could only store up to 9 characters and 1. This is a maximum, at most 9, because we need 1 character first to store our end of the string. All right. So we have that, and the name of the array is a constant, pointer constant. We always say name is a pointer constant. It also happens to be the array. All right. For instance, if your char is a address 32, this address is a pointer constant. Why it is a pointer constant? Because when we declare an array of 32, the compiler or the system, when it executes, it allocates 32 bytes of array 0 to 31, right? Let me erase that. This is the address is defined for this. Okay, let's say the address is 4460 or 61. It's easier, 61. From here 32 bytes are allocated because our char is 1 byte, and the very first address is given a name called address in this case, and that will never change. This is a memory object, memory cells in the hardware, and we need a handle to that. Without the handle we could not access this memory. That's why it's a pointer pointing to the first address, and it's a constant. You can never change it. What does that mean, never change? It means what? You can never do such thing as pointing to something else, let's say temporary address. You could never point any of that. All right. So that is a pointer constant. Okay, let's go back. Let's go back to our. The last character in a string is always a null character. ASCII value of 0, the last character, right? It's represented as \0. To compute the length of the string, we have to traverse from the start of the string until you read the null character. It's not a very efficient, but that's where we have it. Okay, a null character is not part of the string. Okay, let's go back to the whiteboard. Even though we say, let's say our char address is 32, all right, the length of the string maximum at most is 31, right? Because plus we have that, but you can store less than 31. All right, let's say our address is 1111 Washington, BLVD. So how many characters we have? 1, 2, 3, 4, 5. One for the space. 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 characters here. The string length of this is 14, right? Plus we need one character to store for the null character. So in this address, if you store the string 1111 Washington Boulevard, the string length is 14. It's not 15. All right? It's not 15. It's 14 because we have 14 characters. The null character is not counted. Not counted. That's something you have to understand. And it is a must to store a null character in the string. Otherwise, your computer will choke. For instance, if you forget or you made an error and not put an empty 0 at the end, all right, let's say you did not put that, and how would you compute the length of the string? You cannot compute the length of the string because the system will start from the beginning, start counting until it finds this \0, which is a 0 ASCII value, and it will go on counting until it finds. If it doesn't find, it will choke, it will crash. So that is very important. Always this null character goes with the string. Remember that. So if you store a string that is way too high than the allocated cell or the size, again also it's an error. You cannot store a string greater than 32 in this case, right? So that's something you have to watch out when you program. All right? Okay. A null character is not part of the string. When you want to compute the length of the string, you don't count the null character. And even the system, when you want to compute the string length, it always starts from 0. Always. Until it finds the finds the 0. That is, it computes the string length. So let's take simple examples. Here I am storing David in the name. It has 8 cells, DAVID and a \0. So the length of the string is 1, 2, 3, 4, 5. I am storing Johnson, JOHNSON. The string length is 7. 1, 2, 3, 4, 5, 6, 7. And you see, I'm storing the end of the null character at the end of the string. The length is 3. In this case, the length is 0. We have 2 null characters here, 1 and 2. but it always finds the first null character. So ed equal to 2. Alright? So we have different, let's look into declarations. Alright? One way is char name 8 or address 32. One easy way to allocate the memory is char name equal this is during the declaration and initialization you are allowed to do this, not all the time. Okay, let's take this example. Let's say address 32. Washington Boulevard. All right? 1111 Washington Boulevard. What really happens is, in this situation, in this particular situation, this is a string. This is a string somewhere in the memory. Stored in the memory somewhere. Alright? The system allocates memory for this string somewhere. It's hard coded. That means it's part of your program. Right? Like a constant. Let's pretend this is 1111 Washington BLVD, and let's put one null character. What really, this is a hard code memory somewhere in the system, and when you declare an array of char with a 32 cells, the system allocates 32 cells. And it copies the whole thing in here. Alright? 111 Washington BLVD. Alright? It copies. This is a copy. So there are two different strings. You have a hard coded, this is a hard coded string, and the system declares address 32, which is this, and because of this equal, it copies for you. Okay? And this is the only time you can do this. The way it is copied during the declaration and initialization, you can use this equal operator only during the initialization and the declaration, not all the time. Okay, this is very, very important for you. All right. There are other forms of assigning the values to the cells, and we will look into that when we deal with functions. We'll come to that. All right. But for now, remember, this equal operator only works during the initialization and the declaration, or the other way around. It only works during declaration and initialization. Once this is assigned, you have no access to this guy at all. This is gone for you. Okay? You only get this. And address, the pointer constant address always points to the first thing. All right? Always points to the first thing. And now you can compute the length of the address, and you can put whatever you want as long as you don't exceed 31, right? Okay, so remember that. When you use static memory to define your strings, you always have to use double quote here. Constant strings, constants, or hard-coded strings should always be on quotes. On quote, okay? My name is John. So this is a constant string. To define, you need to get the double quotes around it. But the double quotes, this double quote is not part of the string, is only used to define the constant. They do not count for string length. All right? String length is 5, in this case DAVID. The quotes are not counted. The double quotes are not counted. They are not part of the string. The other way to do that, to assign values to the cells, is the individual way of assigning. We'll talk about this now. Let's take our name, array 5. It can be anything. Say char. I can individually name, use the individual cells, single quote. Okay? You know how characters can be defined in using single quote? Those are simple characters. ASCII D. If you want to put, this is our array, right? So 0, 1, 2, 3, 4, and 5. So name 0, when you define the char character with a single quote, then you assign the D in here. You can also assign name when you define single lowercase letter a with a single quote, then it becomes a. Okay, now I have to show you a distinction between a single quote and a double quote. A double quote is a string of characters. Okay, string of characters. And a single quote is just a character. So that's why we are using single quote here. I can represent like that. Alright? So same as for 3. Alright? I'm going to not really worry about filling the rest. Okay. So this is one way of doing it. You can also define name phi equal single quote \0. That means that one, right? So null character. So this is how you can assign values to the character, to the array, either using individual cells with characters in single quote, or you could use, like I said, during the initialization, you can do it. Alright? We are going to look into several ways. Okay. So here, once I have declared my array contents, I can individually change each and every letter the way I want. If I want to change David to Jab instead of David, I need to change to J. All I got to just say J. That's it. So it will change that to J. You want to change I to E, you can change it. You can insert a null character even inside. For instance, I changed here. I can go back and say, let me get a new one. I can say name 3 equal to 0. So I can insert a null character anywhere I want. Alright? That's what this does. So we have seen that. If you change it, it will go and put the J in the right box. We have seen this also. So how do we print and how do we read? Those are two next topics we'll go through. The printing, okay, let me write a program here. For the basic strings, you don't need to call any other function. So this is one way. I'm going to okay, I'm only using 4 cells but only 3 letters. And how do I print it? Printing is very easy, just like we did. My name is %s. S stands for string. Alright, remember that. It's in here. %s. Alright. That's it. If you see the syntax, you are sending the pointer address to the printf function, and the printf takes the array, and it doesn't need to know the length of the array. Why? The printf searches the null character from start to end and prints it. Okay, let's go back to the whiteboard. We have name, right? Sam. So the printf takes the name of the array. In this case, it's a pointer constant, or the pointer to the first element, which never changes, right? So it takes that. For strings, the syntax, when you use the printf statement, printf %s, you don't, this is a pointer constant, and also the beginning, the address of the first cell, and printf searches for the end of character and prints each and every letter for you. Alright, so let's print it out now. Because you are not using any functions, you're not using any string function, you don't have to include any library. So my name is Sam. See that? The very first occurrence of null character marks the end of the string. Okay, let's go ahead and do this. Sammy. All right. Even though I put Sammy, let me print this just to show you. It prints Sam. Two sorry, two letter M's. So let's go back and see. So did I compile it? Okay. What is going on? Let's put the back end of line. Sammy. Okay, you may wonder why it didn't take in the first place. This is a problem with C language. It sometimes remembers the old things because of the memory constant and all those issues. So you have to make sure you always put the null character. So this is one way. The other way is you can sorry 1.c to 2.c. In here I'm going to remove those things. Sammy. All right. So it prints Sam. So there are two different ways to assign variables to string arrays, array of characters. So that's one way of printing using %s. And remember, you don't have to put the ampersand or anything like that. The third thing is, how do we scan? How do we read into it? Right? We saw how to print. Now we are looking into how to scan into it. That means how to read into it. Yeah? It's also very simple. We use scanf %s name. Now you might ask me, why are we not using the ampersand in here? Why are we not doing scanf That's because name itself is addressed to the first letter in the cell, right? We talked about it. The scanf just needs address to plug in the values. and this is the name, address of the very first letter or the cell. So the scanf doesn't require the ampersand. If you just mention the address of the first cell, which is the name by itself is the name in our case, you don't need to put the ampersand. The scanf works the way it is. Let's go back to here. I am changing my name. All right. And you say print enter a name. %s. All right. We don't need ampersand, like I said, we don't need it. Two. All right. Enter your name. So that's all. I'm printing the very first name I had, which is Sammy. Then I'm saying I'm changing my name. Enter your new name, and scanf uses this format specifier %s and plugs in the value the user entered into the name variable, and I'm printing it using %s. Let's compile this. Okay, my name is Sammy. I'm changing my name. Enter in the name. Now I'll say I am Johnson. I'm changing my name to Johnson. You see that? The way I have written it. Just like any other printf, all you got to do is, in case of character of strings, array of characters, you need to use %s. So these are the basic things using strings, right? In the next lecture, before we go into next lecture, we'll talk about things that we did. We know how to declare an array of characters. We know how to initialize the array. We used many methods, and the last one is the scanf. Scanf shouldn't be part of initialization, it's maybe just assignment. Okay, so we know how to do the initialization, we know how to print it, and we know how to read into it. Okay,